Okay, welcome to Peer 1 Chapter 2, Functions and Transformations. Sounds interesting, right? Yes, welcome. Let's continue on Cambridge A and AS level mathematics, Chapter 2, Functions and Transformations. Let's start with this image. There are many situations in the real world where the applications of functions are used. We use function almost every day. Let's recall mathematician Galileo in 1564 to around 1642. He was an Italian astronomer, mathematician, and physicist. Again, guys, pay attention to what we are doing in class, right? He invented the idea of a function to simplify equations, right? He grasped the concept of a mapping between two sets, and he used that to study the relationship between the concentric circles, just like what you can see. Concentric circles. So functions can be used to describe many relationships in our day-to-day activities, including the orbit of the planet around the sun. And that's why the study of these functions and the study of this particular topic is very important. Let's quickly look at the objective of this course. You should be able to understand the terms functions. Conceptual understanding. It takes you back to IGCSE. Terminologies. What is a function? Domain, range. We have different types of functions. Like what you can see is a type of function. So we have one-to-one function. So we have one-to-one function. So we have one-to-one function here, and this is a type of a function. Let me take a highlighter. So we have this type of function, one-to-one function. We have the inverse functions and composition of a function. Under here, we are going to look at composite functions. Again, you are supposed to identify, at the end of the course, we should be able to identify the range of a given function in simple cases and find the composition of two given functions. Determine whether or not a given function is one-to-one as a type of function, and find the inverse of a one-to-one function. Right, it is very elaborate topic. So we are going to look at how we can graph these functions, illustrate in graphical terms the relation between a one-to-one function and its inverse. Then finally, we will look at a very important concept. Understand the use and understand how all these transformations are to be used. We have transformation of a graph y equal f of x equal f of x. Again, conceptual understanding. It takes you back to IGCSE. Before now, we had looked at various kind of functions, right? We have looked at various kind of function. We know linear function, equation mx plus c, right? Linear function. We had also looked at quadratic function, y equal ax squared plus bx plus c, bx plus c, right? Quadratic function. We looked at the cubic functions, y equal ax cubed plus bx squared plus cx plus c. This is a cubic function, or you can say plus d. And then we can look at reciprocal function, y equal 1 over a or y equal 1 over x. We can look at exponential function, y equal a to the power of x. And we have looked at trigonometry function, y equals sine of x cosine of x. Again, it takes you back to the laws of trigonometry and using the trigonometric identities. So here we are going to look at various transformations of these functions. Again, when we see y as a function of f of x, y equal f of x, this is an equation that tells you that it moves the graph up by a. So it is going to move upward by a, right? Again, we have y equal f of x plus a, y equal f of x plus a, f of x plus a. And then we have y equal f of x minus a, minus a. Again, we can look at y equal f of x minus a. Wow, what does that mean? Graph will move right by a. It moves right by a. This is negative. This is positive. When you compute this, it moves left. But negative, it moves right by a. We have graph of negative f into x. It is like you flip the graph upside down. So this is a flip. It is a flip of the graph upside down, right? And we have a graph of y equal to f of negative x. When you have this, you flip graph left right. This is a flip of the graph left right. We can have vertical stretch of y equal af of x. So you should be able to understand what is happening with these functions. We have also horizontal stretch of a graph y equal to f. This becomes y equal so we have f of ax among others. So here you will have your vertical shift. Then we have our vertical horizontal shift. We have reflection in the x-axis. We have the reflection in the y-axis. We have the vertical stretch, and then we have the horizontal stretch. So you should be able to know how these functions are used and what they all implies. So this is what we are going to be covering in this particular topic. So we should be able to plot a table of values for accurate points, and we make intercept for turning point. Those are tips that is required for you to be able to plot a good graph as is required by your specification, Cambridge specification. Before you start, you should know how to write conceptual understanding. Okay, so now substitute into the function f of x. Take the example that you are given. We have f of x. This is equal to 3x. 3x minus 2 root x, right? So we can start with any values. Let's take an integer 1, for instance. If we say f of 1, what this implies is you should be able to substitute this value in the function. So it is 3 times 1 multiplied by 2 root 1. So this is supposed to be 3 minus 2 because 2 root 1 is 2. Right, so this is equal to 1. If we substitute f of 100, it is simply 3 times 100 is 300, right? Minus, if we put 2 root 100, we will simply get 20. So it is minus 20. So this is supposed to give us 280. Conceptual understanding. So this is what you did in IGCSE. And you can go ahead and substitute f of 4. You will get 8. Again, you should be able to sketch the graph of y as a function of x. So it is y equal x squared. And you will get this as your graph. Conceptual understanding. IGCSE. Okay, let's check your skills. Very quickly, try to test your understanding. What is this function? If we try to substitute this value, we have f of x equal 5x plus 2x cubed. Pause the video and tell me what you will get in times of a f of 1. You simply put 1, right? Do that. Conceptual understanding. By looking at it, I can tell that the answer to the first question is going to give you 7, right? Because we have f of 1. So this implies this is f of 5 times 1 plus 2 into 1 cubic, right? This is 5. What is 2 multiplied by 1 cube is simply 2. So it is 5 plus 2. So this is 7. Conceptual understanding. So you should be able to try B up to F. It is simple substitution. Of course, you must be able to understand this for us to be able to work with this particular topic. 2.1 terminology. So let's start by looking at mapping. Mapping. A mapping looks at the relationship between two sets of numbers. The relationship between two sets of numbers. And we can consider times 2 plus 1. So we can input a set of numbers for x. For example, we can have -2, we can have -1, and then we can have 1, 3, 6, right? The input of this number is called the domain. The domain. And that takes you to the output, which will be called the range, right? So the input set is called the domain. The output set can be obtained by applying the operation to each number, as we are going to see later on in this video. We can decide to use the input -2 so that we are able to get the value -3, and this gives us the range of the value. So we said that each number is a member. When you see us write this particular notation, it means a member of the set X. So we can say that X is a member of R, right? X is a member of a set of all the real numbers. All the real numbers. We have talked about rational numbers, irrational numbers. We have also looked at all other complex numbers that uses factorials. So this X is a member of R. So a function, therefore, is defined as a mapping where every element of the domain, which is the x value, is mapped onto exactly one element of the range y value. So you have the x value and you have the y value, which is the function f of x. So every element of the domain is exactly mapped to one element of the range. So the diagram, as you can see, is an example of a function, because we can see that in this domain, all this element is mapping another in the range. So this is an example of a function. So we can write that function in two ways. Either you write your function as f of x to be equal to 2x plus 1. This is a function. Or we can say that f is mapping by this arrow. It is mapping this to x plus 1. Either way, it represents the way we are going to write function. And you can use any of them as we explore now in calculations what is required in this topic. Okay, so now let's proceed to types of functions. Types of functions. When we look at types of functions, we can have what we call one-to-one function. So we have one-to-one. One-to-one function. Now look at this. What is a one-to-one function? If every element in the domain, we know x represents the domain and y represents the range. If every element in the domain is mapped onto exactly one element in the range, and every element in the range is mapped onto exactly one element in the domain, not two elements. If it is mapped exactly one, we say the function is one-to-one function. Right. You can see every element here in the domain is exactly mapping one element in the range. Every element here is mapping exactly another element. Every element. So this is what we have. One-to-one function. One-to-one function. Now we have another type of function, many-to-one function. Many-to-one function. We have many-to-one function. Many-to-one function. Many-to-one. That is, if every element in the domain is mapped onto exactly one element in the range, but some element in the range arise from more than one element in the domain. Pay attention. Every element in the domain mapped to exactly one in the range, but some element in the range arise from more than one element in the domain. So you can see that one element in the range arise from more than one element in the domain. One in the domain, we can see here, we have this one in the range and is arising to have come from two elements in the domain. We still have one element in the domain mapping exactly one in the range. But here we have one element in the range that have arisen from two elements in the domain. So this is many-to-one function. Many-to-one function. So we have many-to-one function and we have one-to-one function. Now here comes the problem in the third case. Is this a function? Of course, no, this is not a function. Why is that not a function? Look at it closely. Look at what is happening closely in this function. Look at what is happening. Look at what is happening. Can you tell the difference between the second scenario and the third case? Look at it closely. Look at it closely. It is not a function because it is one to many instead of many to one. It is one to many. Some elements in the domain are mapped onto more than one element. Like the second case that we have the second case here. It is mapping more than one element, mapping -1 and 1. And when this happened, it is no longer a function. Because according to the definition of function, a function is to map exactly what? One element. We say that a function is defined as a mapping where every element of the domain is mapped onto exactly one element of the range. Onto exactly one element of the range. So when the reverse is the case, the definition of a function no longer holds. In that case, this is not a function. Now let's look at example. Find the range of these functions. Find the range of these functions. So what is the function? We have f of x. The function f of x is equal to x plus 5. And you are given the values, it ranges from x greater than equal to 5. Greater than equal to 5. Okay. The least value of f of x is 5 plus 5 because it is greater than equal to 5. Greater than equal to 5. So if it is greater than equal to 5, 5 plus 5 gives us what? 10. So we are looking at the range of the function. The range of the function. So let's find the domain of this function. The domain of this function, therefore, is going to be, the given domain is going to be x is greater than equal to 5. This is the domain. And therefore the range will be f of x greater than, this is less than, we have greater than equal to 10, right? Greater than equal to 10. So this is the range of this function. Look at the second case. You have x cubed, g of x. So this is g of x that is equal to x cubed. Can clean up that. G of x. So we have g of x, which is equal to x cubed. Look at the domain. You are given -2 less than equal to x less than 4. So if it is less than equal to -2 is less than equal to x less than 4, and our x is cubic, this is x cubed. Simply substitute, it is -2 cubed, that gives us -8, right? And how about 4? 4 cubed is going to be what? 4 cubed is going to give us 64, right? So our range, therefore, the range is going to be -8, right? -8. Sorry about that. negative 8 less than equal to g of x. G of x less than 64. And this is how you are able to compute and find your range and your domain in the given questions. Look at the next example. Given domain is x greater than equal to 5. This is just showing the previous solutions. Of course, you can confirm that what we did is actually correct. Yeah, so this is the answer to this question. The range f of x greater than equal to 10, and the range negative 8 less than equal to g of x less than 64. Let's look at the second example. You are supposed to sketch the graph of the function defined by these functions. F of x, 4 minus x, when negative 2 as the domain, less than equal to x less than equal to n. And we have 2x plus 1 when 1 is less than x less than equal to 3, right? And therefore we are able to find the range. We are able to find the range. So what are we going to do? How are we going to graph this function? Usually you run away, you guys, when you hear graphing, graphical method. Even in solving equations, you can solve equation graphically, and they are very simple and straightforward. So let's see how you should be able to graph this function. Let's look at, first of all, how to find those values that will enable us graph this function. So the first function, we have f of x, right, equal 2x. Let's start with this 2x plus 1. This is 2x plus 1, right? 2x plus 1. So what are we going to do when x is 3? Because under here we have when 1 less than x less than equal to 3. So if x is equal to 3, what this implies is that y is equal to 2 times 3. Remember, it is 2x, 2 times 3 plus 1, right? So what is 2 times 3? 6 plus 1, you get 7, right? So now let's look at the second case. We have y, this is equal to 4 because it is 4 minus 1, right? So 4 minus 1, this function, 4 minus 1, or 4 minus x. So this is when x is equal to, because it is negative 2, right? So when x equal negative 2, so what you are going to have is going to be what? Y is equal to 4. So we have 4 minus, so this is 4 minus 2, right? So minus to become plus, so this is 6. Now let's look at the next case. The function f of x for 2x plus 1, when x is equal 1, when x equal 1, we are going to have y is equal to 2 times 1 plus 1. This is 3, right? And finally we have the function f of x. We have solved 2x, so now we go back to 4 minus x, right? When x is equal to 1, so this becomes 4 minus 1. 4 minus 1 is going to give you 3. So now we have our graph ready. We can have the coordinates 3, 7, we have the coordinate 3, 7. We have 3, 7, and then we have negative 2, 6. We have negative 2, 6, negative 2 and 6, and then we have 1 and 3. So those are the coordinates that we have. Negative 2, 6. We have 3, 7. And then we have 1, 3. Now you can graph. It becomes very easy to do that. Don't mind my sketching. Kindly use your ruler to do this better. So we have our y-axis and we have our x-axis, right? We can have 1, 2, 3. 1, 2, 3. So this is 0. We have negative 1, negative 2, negative 3. So we can have 2, 4, and 6. Right, you can even have 8. Then we have 0, right? So 1, 3. 1, 3 is somewhere here after 2. 1, 3. And then we have 3, 7. So this is 3 up to 7 after 6 somewhere there. And then we have negative 2, 6, negative 2, 6 somewhere here. And you simply draw a straight line to join all these points. So here, and then we have negative 2, 6 is here. Then you simply draw your line to join, straight line. Don't mind my sketch. So this is how your graph should be able to look, and you should have been able to solve the first question, sketching the graph of the function defined by the given equations. B, you want to find the range. The range becomes very easy because we have already solved. B, the range of this function is going to be what? 3 that we got. We have 3, right? So it is 3 less than equal to that function f of x less than equal to what? To 7, right? So this is the range of the function, and this is how you are able to graph and also to compute the given range. Now you can test your understanding in question B. You can as well confirm what we have done and see that they are correct. What we have done, we have shown how to get this value 7633, and then we are able to have our graph and then compute the range of the given function. The next example, h of x is equal to 2x squared minus 12x plus 22. X is a member of R. Express h of x in the form a into x plus b squared plus c, and then find the range. So h of x is given as 2x squared minus 12x plus 22, and we know that x is a member of real number R. Conceptual understanding. So now we want to express h of x in that form. So we can have, let's factor out 2 so that we have x squared. This is 12 and 22, so this becomes negative 6x plus 11, because 2 by 11 will give you 22. 2 by negative 6 will give us 12x. So this will be the first step. Now we can use the method of completing the square as we did earlier in chapter 1 quadratics. And you know how you complete a square, right? Simply take b, this is b here, right? So b is 6, divide by 2, you get 3. And when you square 3, you get 9, right? So we complete the square. So this becomes 2. So we're going to have x minus 3, which is half of 6, square this, then minus 9 plus 11 that we have here, right? That is completing the square. Simplify this to get, this is x minus 3 squared, negative 9 plus 11, you get positive 4, right? Positive 4. So you have expressed this in the form of a into x plus b squared plus c, completing the square. This is the required solution. B, you have to find the range. The range, we can use 2 into x minus 3 squared. Cannot be less than 0. This cannot be less than 0. It cannot be less than 0. It cannot be less than 0. So if it cannot be less than 0, what happened is that the least value of h of x in terms of the range, the least value of h of x is going to be 0 plus 4 that we have, right? 4 plus 0 is 4. So therefore the range is going to be, let's take a different color. The range is going to be what? h of x greater than equal to positive 4. So this is the range of the given equation. Try to go through example number 4. Go through example number 4 here, that we have 5 divided by x minus 2 squared. First of all, you will try to remove this fraction and then simplify by completing the square. So when you do this, you can confirm if your answer is right. I have included the solution, and then try the exercise of this 2.1 question that we have, so that in the next video we are going to continue with composite function. So I have included all the exercises required for this particular topic in this stage as required by Cambridge specification. So you can go through this, and I will be leaving the link below the video for you to check the answer for these exercises, and we should be continuing with composite function in our next video. See you. Bye.